So Scott Fuller is a chief engineer in electrical architecture and synthesis at International. If you don't know International, it's because for about the last or up until about 3 weeks ago, they were named Navistar. So Scott has over 35 years of engineering and knowledge management experience. He has a diverse range of professional experiences, from developing custom IT solutions for companies like Dow and DuPont, to developing the tools and processes used to engineer electrical systems in the automotive and trucking industries. So today, Scott's going to walk us through a few fundamental principles and how they're being used in an Auros community practice to support electrical harness design at International. All good?
Really need it anyways. Auros coach, she is my Sherpa, because the path I want to tread is a little orthogonal to the norm, and she's been doing a great job leading me up that mountain. Thank you, Rick Ridgway. I went to Rick about 10 months ago with this crazy-ass idea, asking, can Auros help me with this? And Rick said, yeah, it can, Scott. Let me show you a couple of things. And he did, and then got me in touch with Camille. Big thank you to those two individuals. My name is Scott Fuller. I am a chief engineer at International, responsible for, I want my 8x10s in Handmule photo rag, not that cheap crap, okay? I'm a chief engineer at International, responsible for the architecture and synthesis of the electrical harnessing that goes on our product. And at International, we build snowflakes. Something's jacked up already. Okay. Oh, I'm sorry, we're past that. We build snowflakes. Yes, we do. I don't have to use very much hyperbole to say that no two trucks coming off of our assembly line are ever the same. Here, let me show you something. Every truck has fundamental features on them: exhaust systems, fuel tanks, battery boxes, solenoid packs, things of that nature. On an International truck, these devices could be found in one of many different locations. And if we don't locate a device where you want it as a customer, for a fee, we will engineer a solution for you. As such, we have configurations that go on forever. But it gets worse, because once we figure out where to place your device, we then have to figure out what flavor of device do you want. Do you want aluminum fuel tanks, or do you want stainless steel? Do you want Raycor fuel wire separators or Davco? And then once we figure out the brand, we need to figure out what is the right model for your truck. Do you want 3 batteries in that battery box, or do you want 4? And how do you want them configured? But it gets worse, because trucks, like your car at home, were originally a product of mechanical engineering, made up of steel, springs, gears. The most advanced aspect was the thermodynamics, the internal combustion engine. As such, companies have developed procedures, methods, processes to bring that mechanical product to the market. But we can't say these trucks or your cars are solely a product of mechanical engineering. Not anymore. They're just as much a product of electrical systems engineering, made up of wires, communication networks, sensors, microprocessors, and a boatload of computer programming. And all these processes and methods to bring a mechanical product to the market are awkward at best for electrical systems. Still gets worse. Within the electrical department, no one engineer owns a harness design. No one owns a print. Kevin David may release an initial print, initial design, but a few months later, Melissa Rodriguez might revise that design. A few months after that, Kyle Upton might revise the design again. A year later, Ravi Nikam might void out that design and replace it with a brand new design. It still gets worse. All the engineers that can do release harness work aren't in the same location. Many are in our corporate headquarters with me in Lisle, Illinois, but we have engineers who are working in Michigan, Ohio, Indiana, Texas, Oklahoma, Florida, Mexico, India, soon to be Sweden, Germany, and Brazil, which means not all these engineers speak with the same mother tongue. Yeah, it still gets worse. This one's going to blow your mind. All the engineers that can do electrical harness release work, they're not even all in the electrical department. We have 2 custom engineering groups that are authorized and are supposed to release harness designs. We have manufacturing personnel that can do the same. We partner with an engineering house. We even have tier 1 suppliers with engineers authorized to make revisions on our designs. What I've been trying to tell you for the past 3 minutes is that at International, we have complexity upon complexity upon complexity, ad nauseum, ad nauseum, ad nauseum. But enough about me and International. Let me ask you a question. Do you know how to fill a jar? Well, if you don't, let me help you out. Step 1, get a jar. Step 2, find some rocks. 3 to be precise, and they should be of such a size that you can fit those 3 rocks fully in the jar, but no more. After that, get some gravel, pebbles, and start pouring those in. Now here it's going to be beneficial if you stop pouring every once in a while to shake that jar. They'll kind of settle. You'll be able to fit more in. But if you're consistent with pouring and shaking, you will eventually fill that jar up from bottom to top with gravel. Next, get some sand. Start pouring that in. Here it's going to be highly beneficial if you can have someone help you. Kind of shake, vibrate that jar as you're filling the sand in. But if you're persistent, you will fill to the top with sand. Lastly, get some water. And please, slowly pour it in. You don't want to make a mess of things. In my presentation, I'm not going to talk about the water. That's minutia. That changes not just from company to company, not just from department to department. It changes from use case to use case. It makes no sense for me to talk about the water. The sand, those are the details. And they too change from company to company and from department to department. Makes no sense for me to talk about the sand. The gravel, those pebbles, well, those are the things that are very unique to each company. The gravel we use at International is going to be very different than the gravel you use at your company, so I really shouldn't talk about that very much. But those rocks I'm going to talk about because they are fundamental concepts and they do not change, period. They're the bedrock from which we all can build upon. But to be honest, these rocks aren't revolutionary. They're not unique. They're not new. They're the opposite. They're old, they're mundane, they're simple, laughably simple. In fact, you know these rocks. My fear is that when I'm done talking, you're going to be thinking to yourself, that's it? That's what Scott wanted to talk about? Oh, please, get the next speaker up here. You just wasted my time. However, I am confident, because I've been watching you guys, I think I'm going to get a nice little golf clap. Hey, Dee, I'm trying to set expectations. How am I doing? So far, so good. Excellent. Молодец. The America's Cup is the oldest international sporting event still in operation today. It's a sailboat race between a defending champion and a challenger, and it takes place every 4 years, give or take. And this race is aptly named because from its inception in 1851 all the way up to the year 1992, a team from the United States has won that cup every single time except for twice. USA, USA. And then in 1995, a team from New Zealand, the Kiwis, beat the Americans. And then in 2000, those same Kiwis were defending the title and beat the Americans again. How? Well, the Kiwis were led by a gentleman of the name Sir Peter Blake. And good old Petey implemented a rigorous review process. When it came time to make decisions about the boat's design, the components they had used, the sails, it had to go through this process first. When it came to selection of the crew members, when they had trained, how they had trained, eating, sleeping, in fact, every single decision to be made had to go through this process first and foremost. And this rigorous review process consisted of a single question. Will it make the boat go faster? Simple, yes? Laughably simple. If you were to Google America's Cup, New Zealand, will it make the boat go faster? You're going to be hard-pressed to find very much about these miraculous back-to-back wins. But what you will find are hundreds of consulting firms, all built upon the principle of, will it make the boat go faster? If you were to take that statement, will it make the boat go faster, as it is spoken in its native language, naval-ese, and translate it into international speak, my native language, that statement, will it make the boat go faster, translates into, will it help me hit my release dates? I'm not kidding. Scout's honor. I was never a scout. If you were to come to me and say, hey, Scott, I got some ideas on how to improve your harness development process. I got some tweaks you can make. I've got some tools you can use. I've got an IT solution for you. The first words out of my mouth will be, will it help me hit my release dates? Well, what it's going to do for you, Scott, is you're going to be able to store all your specifications requirements in a single repository. I don't care. Will it help me hit my release dates? Yeah, but what you're going to be able to do is create these things called assessments, and then you're going to be able to review your engineer's work, and I don't care. Will it help me hit my release dates? Look, I don't care if your solution serves me up a top-shelf margarita on the rocks with salt on the rim. Will it help me hit my release dates? That's all I care about. If you say yes, prove it. But if you prove it, I'm yours. Mind, body, soul, heart, and I'll want to hear every word you have to say. But until then, I don't care. I have thought a lot over the years about what it means to deliver on time with quality. And I've come to the conclusion that I need three fundamental things in place. Three basic principles, three fundamental concepts. I need three rocks. First rock, I need a consistent, repeatable, reliable process. I need all my engineers marching to the same beat of the same drum, because once they are, it's really easy to direct them. Engineers, march due north. March, march, march. Engineers, march 12.51 degrees to the east. March, march. Engineers, stop marching. Easy. But if they're not marching to the same beat of the same drum, I might as well be herding cats. Second rock. I need training and doing to be one in the same. I want to take a brand new engineer, whether they're fresh out of college or a 25-year veteran, preferably from my competition. I want to walk them over to the computer, have them turn it on, and point to the tools, the applications they're going to use, and then walk away. Third rock, I want my engineers to be the sole source of everything. I want my engineers to determine what their deliverables are, not someone else. I want my engineers to identify the requirements, not someone else. I want them to identify their inputs, review those inputs, validate those inputs. I need them to do all the work, and yeah, I need them to review their work, test their work, validate their work, and then release their harness designs. And oh, by the way, I need them to do this with no oversight whatsoever. I know, it's a knee slapper, right? Because that's pure fiction. I'm living in a fantasy world. Even that first rock, a consistent, repeatable, reliable process at international? You saw our complexity. We don't have exceptions to every rule, we have exceptions to every exception of the rule. And yet, I gotta have these three rocks firmly in place. You wanna know something? I think I discovered the secret. Computers, technology, automation, duh. And I've taken automation and I've categorized it into four separate groupings along a spectrum. At the top of the food chain is the easy button. Hey, Scott, we need harnessing for the new 500 kJ 1939 backbone. No problem, easy, bing. The only issue is there is no easy button for full harness design, so I can't do that. But what I can do is scour every task an engineer performs. And many of those tasks I have, and I will continue to automate. Because given a choice between having an engineer perform a task and a computer, it's no choice. Computer every time. No offense, engineers, I love you. I'm one of you. But let's face it, we're slow. And sometimes we make mistakes. Computers are fast, and they do exactly what you tell them to do. The only trick is knowing what you tell them to do. The next best thing is to have the computer check your harness designs for you, check your work. In the harness development tool set we use, we have this thing called design rule checks, or DRCs for short. And the way it works is that when an engineer is done designing their harness, they press a button on that tool set, on that tool, and basically they're saying, computer, please check my work for me, I'm done. And the computer goes, gladly, and then it's off to the races. With lightning speed, it's going through every component, every attribute in that design. It goes to the connectors and it looks at all the additional components, making sure the right TPAs, CPAs, locking features are in place. It looks at the wires going into that connector and hey engineer, look what I found. You got a wire going to the cavity of this connector and it doesn't have a seal on it. That's not allowed, that's bad. And the engineer says, you're right, computer, that is bad, and you saved my butt. Oh, thank you, what would I do without you? It's kind of like Microsoft Word. It tells you when they make a spelling mistake or grammatical error, except our DRCs prevent the engineer from releasing their design until they fix the issue. Let's see Microsoft pull that one off. I'm a Mac guy anyways. All right, third on the list. Here we are starting to get some distance between us and automation. We don't have easy buttons. We don't have ways of preventing the engineer from releasing a mistake. So what we have done is we have provided the engineers with the ability. We've actually empowered them to go and look at very specific aspects of their designs, to pull data on it and look at that data and, oh shucks, they're just reports. But these reports really do look at specific aspects of a harness design, and it presents the data, the information, in such a simplistic way that it's not possible not to understand what's going on if there's an issue. And when I mean simple, I mean Big Bird would be proud to show our reports to a 5-year-old. I'm assuming you don't know much about the wires in a harness, but they're defined by a number of attributes. The circuit number, the part number, the length of the wire, the gauge of the wire, how big the diameter is, the type of insulation, yada, 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 yada. This wire has changed. One of the attributes has changed from one revision of the print to the next. You tell me which attribute changed. It's kind of hard to miss, isn't it? All right. Bottom of the food chain. We are now in a land absent of automation. Here there be dragons. How do you handle this? Auros! Yeah, Auros to the rescue! Can you believe it, Dee? 18 minutes and I'm now just getting to Auros. I guess it shows you don't always get what you pay for, does it? All right, actually Auros is really good with these bottom two categories. But before I talk about Auros the hero, I do have to talk about Auros the villain. And Auros is not the villain because it's evil. Auros is the villain because we at International made it the villain. I'm not exactly sure how it came to be, but I do have my suspicions. I think someone from on high, someone who knows nothing about electrical systems development, someone like a vice president. I got a feeling that a vice president made a decree. Thou shalt use Auros. It has been said, let it be done. And then there's a fury of activity. Engineers scouring all the kingdoms for specification and requirements, caging them into K-packs, cobbling the K-packs together to create assessments. Let me show you something. This is a real assessment in electrical at International. And the way it typically works is something like this. When an engineer is almost done with their harness design, they go into Auros, they select the appropriate assessment, could be this one, and then they start going through it one K-pack at a time. Thou shalt always, and whatever. Yeah, I conform to that. Conform. Prove it. Oh yeah, I guess I'll just throw up these Excel documents, that should do. Next K-pack. You must always, what? That has nothing to do with what I'm not applicable. Why? Oh yeah, this K-pack does not apply to my release package because yada, yada, yada. Next K-pack. I must always listen to my mother and when she's always right, even if I'm wrong. What? Well, I can't comply to this. I'm close, but I can't comply, I guess. I have exceptions. If you wish to deviate from conformance, you must submit a record decision and get sign off from a manager. Oh yeah. Dear manager, I am unable to comply to this KPAC. Please allow me not to. Yours, engineer. Send. Manager. Dear manager, please. No, denied. Send. Engineer. Dearest manager, pretty please allow me not to conform to this KPAC. It's just not possible. Sincerely yours, engineer. Send. Manager. No, denied. Engineer. My most sincere, dearest manager, pretty please with sugar on it, allow me not to conform to this KPAC. I can't possibly meet it, but I do come close. Sincerely yours in technology, engineer. P.S. My release is due in 48 hours. Send. Manager. Approved. Is it any wonder all our managers have gray hair, if they have hair at all? An engineer is supposed to do this, one KPAC at a time. And look, there's 154 KPACs in this assessment. 154 KPACs, an engineer has to go through one at a time doing just what I described. If my engineers had 1 or 2 release packages due every 6 months, this might be doable. It's not D. But it gets worse, because someone has to review this assessment. Someone's got to go through and validate that what the engineer said is accurate and true. Who is that idiot who thinks this is a good idea? Who is the... I'm okay. Clearly, this is not the answer. So what is the answer? I don't know, to be honest. But I am willing to share with you what I'm trying to do to resolve this issue. And before I do, again, word of warning, there's nothing up here that's fancy. There's no rocket science, there's no trick plays. You already know this, these are fundamentals, okay? You've been warned. Let's start off with a KPAC. And let's start off with the name of KPAC. And let me tell you what Camille has taught me. That name field is not a name field. That is a horrible thing to call that field. It is the specification. It is the requirement. And every engineer doing release work of electrical harnessing and international knows exactly what's expected by just reading that field alone. While I'm at it, I should probably tell you how I personally differentiate between specifications and requirements. To me, a specification is technical. For example, the voltage drop across any circuit shall be no greater than 0.5 volts. That's a specification. And there's better ways to handle specifications, so I don't have them in very many KPACs. Things like DRCs, easy buttons, things of that to get that done and validated. Most of my KPACs are requirements. And to explain that, let me go to the description field, okay? Which again is a misnomer. Most of the tasks my engineers have to do are running of tests, running of reports, looking at the data of one report, comparing it to the data of another report, marking things up. I explicitly explain in detail how to run those reports, how to compare those reports, how to run a test. I also will include a document attached to that KPAC in its full marked up comparison glory so you can see what a final result really looks like. If I cannot list and itemize and explain all the details that need to be followed, the instructions, I'll put them in a PDF and I'll attach it below, and in the description field I will say, see attached instructions below. Gets better. After this, we have the documentation that's being required to upload as evidence. I'll be honest, not all my KPACs require evidence. Stop requiring your people to do non-value add work. It makes the boat go slower. Irritates me too. I'll also provide links as necessary. So again, they'll have examples of the documentation that they need to upload. Gets better still. At the bottom of the description field is criteria for compliance. This is where I explicitly state what it means to conform to this requirement. I explain if you're allowed to deviate, in other words, meet the spirit of the law if you can't meet the letter of the law. I'll also do the same for not applicable. And by the way, not all of my K-packs allow an engineer to hit any other button but conforms. Auros people, pretty please, update this tool so that I can disable any button for any K-pack I want. I don't want to tell an engineer they can't hit the exceptions button. I want to make it impossible for them to hit the exceptions button. The Auros people are going to hate me for that, aren't they? Customer's always right? All right, it gets better still. Every K-pack has something associated with it. It's called an extended element. And I'll be honest, I am not a big fan of the name extended element. It sounds like someone went out and spent a whole dollar on a fancy word when they could have spent 5 cents on a simple word that worked just as well. But I love extended elements. They're just tags, a way of sorting and filtering your K-packs. So in this first group of extended elements, it's all about what print type we are releasing our designs on. We have parent prints and child prints. We actually have 4 different child prints. We have these things called F9Xs, C9Xs, D9Xs, X9Xs, and none of this means anything to you. But your takeaway is that we have 5 distinct print types, and every one is unique. So I have tagged every single K-pack with the print type that it applies to. Some K-packs apply to all print types. Some only to the parent, some to all the children, some to specific children, some to weird combinations of all the above. The next group of extended elements is all about the functionality that that harness has to deliver. It has to perform. Right now, there's only 4 to choose from, right? Standard functionality, purchase assemblies, fusing and relays. So let me take a little sidebar for a moment. I am a big fan of Kaizen, continuous, thoughtful, even very slow improvement. Right now, my snowball is really small, and I'm just starting to roll it down the hill. But this baby's gonna get big. I don't wanna rush it. I wanna do it right the first time. I'll take the hits from my boss and say, yeah, I need another 6 months before I roll this out. Because I know when I do roll this out, our boat's gonna be flying with quality. All right. The last group of extended elements is me grouping those K-packs in order of operation, when they occur, when they need to be validated. And that's all process is, order of operation fundamentally. All right, let me kind of show you how this all comes together. The first thing an engineer does before they even begin their release work is go into Auros, open up the assessment, and go through the gauntlet, entering in non-value add information. What's the engineer's name? Joe Smith. What program am I working on? I don't know, C92. What's my release number? Yada, yada, yada. You know the deal. But once you get past the gauntlet, you get to this field. And now the fun begins, because you see 2 of those groups of extended elements. In the first, again, it's what print type. So I'm going to say I'm an engineer and I'm working on a child part, specifically an F9X. So I select F9X. Then I'm going to say I am working on a harness that has standard functionality as well as fusing. So I'll select those 2. Right? And now I hit the create assessment. And Auros goes out and grabs only those K-packs that apply to the extended elements I chose. Only brings back the K-packs that apply to the work the engineer is performing. And look, there's only 17 K-packs. Again, my snowball is really small, but once it's big and massive rolling down the hill, if I do this right, the most number of K-packs our engineers will have to deal with is 35, 40 at best. And that's if they're developing the most complicated harness they ever did from scratch. That's doable. But it gets better. So again, I said that all the K-packs are kind of grouped in order of operation, and you can't see them now because they're all condensed. So let me uncondense the very first one, okay? This actually is the very first task a harness engineer needs to perform. They need to mark up their design intent, what they want that harness to look like, how it needs to function. This is a real critical task. So this K-pack has everything an engineer needs to know about marking up a print. It refers the engineer to the markup standard that's attached below. It explains in wonderfully, beautifully childlike details, 5th grade reading level, what it means to mark up a print, what you're allowed to do, what you're expected to do, what you can't do. It also provides lots and lots and lots and lots of details, right? It also has the markup template. So no one has to go anywhere else. Everything you need to mark up a print, the tools, the instructions, the expectations is all right here, okay? This is actually a deliverable. It's an output. And ideally, I want someone to review this KPAC first and foremost. Please, 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 please. Update your tool so that I can assign reviewers to any KPAC or group of KPACs. I need to sign off and validate as the process continues in real time. I can't afford to wait till the very end to have someone sign off and say it's all good. They're never going to invite me to speak ever again, are they? No, I blew it. All right, so this is an output, right? And it's going to be handed to another engineer. This may sound like non sequitur, but I promise you it's not. I love the Olympics, in particular the track and field events, mostly because that's what I ran in high school. And let me tell you this, when you see a runner in a relay race just flying down the track, it does not matter how fast they're running. It doesn't matter how much they're sweating. That baton is secure and firm in that runner's hand. But when they go to hand it off to the next runner, sometimes they don't get in the palm of that runner's hand quite right. Sometimes it gets bobbled. Sometimes, in the worst case, it gets dropped. The greatest opportunity for errors and issues occurs at the handoff between one engineer and another, one department and another, one silo and another, which is why it's so important to review this KPAC in real time. Handoff gets handed over to a systems engineer. They're going to do some work for a couple of weeks. And now that engineer is going to kick out their own deliverable, their own output. And that output's going to go back to the harness engineer, another handoff of the baton. So this second group of KPACs walks the engineer through everything they need to do to identify that input, review that input, validate that input. We have to make sure that that input is comprehensive, error-free, completely understood, no surprises. Again, this really isn't new, right? Groups 3 and 4, they're just the critical task of the engineer doing the work. And to be honest, they're non-sequential order. Group 3 is all the administrative tasks an engineer has to do, and you would not believe the amount of administrative tasks we have to do. But those are easy things to look at, so I don't want to waste the time of an experienced engineer. A peer engineer can check those. Group 4, though, those are the critical ones when it comes to design. The very critical, the things that we have to meet, we have to conform to. So you better believe I'm going to have an experienced engineer review those KPACs specifically. Right? All right. Someone's got to review this assessment. And there's a process for that. And again, process is just order of operation. What you do first, what you do second, what you do third. So the first thing I want a reviewer to do is look at all those KPACs that have been marked exception. Because that means we went off the rails a little bit. We're not meeting the letter of the law of that requirement. We're hopefully meeting the spirit of the law. So I need an experienced engineer to put a critical eye on those first and foremost to confirm that, yes, it was not possible to meet the requirement as stated, but the engineer did meet the exceptions and the cases where it was stated explicitly in the description field. When the reviewer is done looking at everything that is marked exception, then I want them to look at those that are marked not applicable. Because I've worked really hard to try to make sure that this tool only brings up the KPACs and puts them into the assessment that applies to the work being performed. But once again, you've seen our complexity. I can't even begin to imagine all the exceptions to the rules that exist out there. So again, an experienced engineer really needs to look at those. And now I'm going to blow your noodle wide open, because I know what every one of you is thinking. Yeah, Scott. Then the reviewer checks those that marks conforms last. No, not at all. What do you mean not at all? No, I don't want anyone checking those. Why? Well, what if the engineer made a mistake? They won't. What if they do? But Scott, look, there's only two reasons why an engineer would say they conform to a KPAC when they don't. The first is if the KPAC was not written explicitly enough. And if that happens, that's my bad. And that's why I review these KPACs with engineers who speak with different mother tongues, who are working in different departments, different locations, so that the time I do release a KPAC into the wild, it is truly vetted. The only other time an engineer say they conform and they don't is if the engineer did not read the instructions. And now, we got a performance issue. But don't worry. That engineer will get the mentoring they need to learn to march to the beat of our drum. But if they can't do that, I'm going to have to find that engineer a new home. Because following instructions that Big Bird is proud of is the easiest thing my engineers are ever going to do. Our product is incredibly complex. That drives incredibly complex processes. And because of that, we hire damn good engineers. I am proud as can be to be one of them. I don't ever expect to have this be an issue. But if it'll make you feel better, yes, we're going to look at them, but it's just going to be a glancing look, because that's all it takes. Oh, holy guacamole. I was given 45 minutes to talk. I have blown through about 38, 40 minutes of those, so let me bring this to a quick close. None of this is rocket science. In fact, none of this is new. You guys have been doing this for years and probably don't even know it. Every time you want to travel, you go to one of those websites, it asks you, where do you want to travel? I want to go to Florida. Great. You want to go to Daytona, Key West, Orlando, Jacksonville? Ooh, Key West. All right. Do you want to stay in a Vrbo? Do you want to stay in a hotel? Do you want to stay in a cottage? Cottage. Do you want golf amenities? Do you want swimming? Do you want a full bath and kitchen? Right? You select your criteria and the tool gives you acceptable options. It's the exact same thing. But given that, this is just me doing my best to try to create a consistent, repeatable, reliable process. A process where all my engineers are marching to the same beat, the same drum. This is me trying to create a process where training and doing is one and the same. Because I'm sincere when I say, if I was to review one of these KPACs or one of these assessments, I wouldn't even be able to tell if the engineer is doing it for the first time or the 100th time. And this is me trying to create a process where the engineer is responsible for everything. Auros walks the engineer through the process. It helps the engineer identify their deliverables, their inputs. It walks the engineer through how to identify their inputs, review their inputs, validate their inputs, do the work, do the same on the back end. Have we reached the state of engineering nirvana? Not even close. But Kaizen, small little steps. The snowball is small. A year from now, it's going to be massive. All right. What questions can I answer for you, and don't hold back? Hit me hard.
Scott, I was curious, did you come into the seed project with this configuration in mind, or did it kind of evolve over the course of the project?
Good question. The idea is not new, right? We've been doing this for decades and decades and decades. So I know what I want to achieve, right? And I kind of put this in mind. IT solutions are not about IT solutions. They're about everything else. I know what I want. I want to tell a computer what work I'm going to do. I want the reply to be, great, this is how you do it in cookbook fashion. I don't know how to get there, though. So that's why Camille has been so phenomenal. When we first started working, she didn't really get what I was trying to do, and I didn't get what this tool did. But we eventually worked through, had a couple of backtracks, had a couple of restarts, but now we're just moving along swimmingly. I couldn't be happier with Camille. So it's kind of a little of both, I guess.
Any questions in the audience? Sanjay?
Scott, I'm intrigued by your mentioning of the letter of the law and the spirit of the law. Would you mind elaborating your bias in that?
Would you like an example?
Yes.
Okay, so here's a really good example. We had about a year ago a feature that was not meeting fundamental specifications. Again, it's kind of like that voltage drop. We just couldn't meet it. No matter what we did, we could not meet it. But specifications are written very poorly. All they are in most companies is, thou shalt not go over 0.5 volts for any one circuit. But there's no explanation of why that specification exists, and are there exceptions to the rules? So what we ended up doing is spending hour after hour after hour with chief engineers and directors and technical specialists, wasting time trying to figure out, can we live with this? Can we not? Should we test it? And then someone had the bright idea, well, we don't create this device. We need to go to the manufacturer of this device and ask them, what does it take to perform? And we found out in that case, no, it performs beautifully at 0.7 volts, at 0.8 volts. As long as you're under 0.10 volts, you're perfectly fine. But that's never in a specification. So we need specifications. We need requirements that tell you, look, ideally we have a common requirement. It's a safe requirement that covers all conditions, we know that. But we don't know a lot of those little details of when the deviation comes and when it's not quite as strict and when it's more strict, right? So if I document that, and hopefully it's a learning tool where as you come along, I will update that KPAC. In this situation, yes, you can deviate above 5 volts, but no more than 7. Does that answer your question?
Yeah, it does.
Thank you.
And I would say we would add that to the stop sign law and traffic.
We have a couple really good questions in the app. Where did you learn to present like this? Great presentation.
I owe this to one of my MBA professors. He explained to the class that he teaches this class term after term, year after year after year, and the material is the same. He says, if you want me to know that you learned the material, don't break the cardinal rule. Do not be boring. If I don't listen to what you're saying, I don't know if you learned the material. So for that term, I took it and ran with it, and I've kind of never stopped.
Love it. All right, at the end, did Auros make your boat go faster?
It's making our boat, yes. So here's yeah, it does. And in all seriousness, so my directive from my director is to get every hardware harness team following the exact same process, which is nuts, right? No one's following the same process. So this is what we're doing. And we started doing this, right? And again, we haven't rolled it out, but I've given various teams these requirements on how to mark up a print and how to review the input coming back. And I got people, again, who don't speak English all that great because it's not their native language. And they came back and said, I'm not quite sure about this, and we update the the KPAC so it's more explicit, easier to read. And then about a month after that, they're like, why haven't we had this longer? Why? We've been asking for something like this for years. We're told how to do things. The knowledge is in engineers' heads. But that's it. You can't get it out of an engineer somewhere else. You go talk to that engineer, right? So our boat's flying just at the start, and I haven't even rolled the damn thing out.
That's great. Any other questions from the audience? Frame?
No,
You're good?
This is fun. Keep them coming.
All right, Scott, thank you so much. That was really entertaining.
Thank you.